There is so much to talk about, but first thing first, the author's copy arrived and it is massive. Literally, no images, nothing. It's just pure text, but it is a work of combined over a decade where it talks about incorporating biointelligence in terms of different biorhythms within the human being, connecting it to artificial intelligence in order to harness the biointelligence that we already have, that we know some about, and much more that we don't know about. It also talks about analog versus digital versus hybrid computing, and both on the software and hardware level in terms of analog resistors that could potentially add additional efficiency to the future work of improving artificial networks as well as robotics, such that they can be combined with harnessing biointelligence from various signals that we can today harness via non-invasive wearables, but also very futuristic in terms of what could possibly be. So I'd say half of this book is probably based on what existing science and technology work, and then the rest is expanding our thoughts in terms of what could be, and a lot of ways, both practical and visionary ways in which this could potentially happen. And it is on Amazon, as you already know. The next thing I want to emphasize on is that in this channel, we talk about neuroscience, biology, and artificial intelligence, and speculative AGI, ASI, and robotics of future, among other topics. But it is important to kind of distinguish between different parts that we talk about. For example, last time I talked about spatial computing, and then prior to that, I was talking about neuromorphic computing. So I think there was a bit of a confusion as to spatial computing is also within the realm of artificial intelligence technology. That is not the case. So my thoughts move in like speed of light, and obviously I have sat with these thoughts forever. So sometimes I have a hard time to, talk about. I set the stage in terms of what it is that we're talking about, so I should do a better job in that. And I should have clarified that spatial computing that I was talking about last time, particularly that particular topic that I was talking about, had to do with the neuroscience. So it is within the neuroscience discipline. It is one way in which, for example, Professor Miller at MIT explains working memory, interplay of beta and gamma waves, for example, right? But you also have spatial computing in the realm of VR. So that was not what we're talking about. I thought it was clear, but apparently not. And then when we talk about, for example, hybrid computing or neuromorphic computing, those are also areas in which, for example, you talk about how these resistors or these computing powers, they're trying to mimic the way in which brain processes information. So that distinguishing capability, I highly encourage you to have it, because science is ever evolving, so is technology. And so a lot of things that we talk about, it's already existing knowledge, but also we are expanding our thoughts in terms of stretching it. And that is how science evolves. And so science and technology, they are ever evolving disciplines. So is all other disciplines, of course, but more so in science and technology. And so it's it's a never ending quest and endeavor. And so the areas that we talked. And so today I want to read for you the part that talks about neural oscillation, aka brain waves, and consciousness. And this topic, while sounding philosophical, it is still under investigation and scrutiny of many scientists. In this case, I will cite Professor Miller's work at MIT because he is one of those who is feeling pretty strongly about consciousness being as part of the electrical activities of the brain, aka brain waves, aka neural oscillation. And then towards the end, I'll talk about how we can also potentially think about these neural oscillation in consciousness, if you want to define them as such, and how it could potentially be incorporated into future AI systems such as the speculative AGI and ASI. Understanding the dynamics of neural oscillations such as alpha, beta, gamma rhythms or brain waves has long been a focus of neuroscience research. These oscillatory patterns reflect different aspects of brain function and are thought to play crucial roles in cognitive processing and consciousness. Recent neurophysiological studies have identified a key interplay between these oscillations, aka brainwaves, providing insights that could have profound implications for both neuroscience and the development of advanced AI systems. Alpha beta oscillations, which range from 80 to 30 hertz, exert an inhibitory control over gamma oscillations, which are higher in frequencies, and their associated neural spiking activities. The inverse relationship suggests that the presence and strength of alpha beta activity modulate the higher frequency gamma frequencies, serving as a regulatory mechanism that can either enable or constrain cognitive processes. Such inhibitory control has been proposed to be part of a larger framework known as the predictive routing model. According to this model, alpha beta oscillations inhibit cortical activities that is predictable, thereby allowing the brain to focus on and react to less predictable stimuli. Most recent scientific studies, Miller et al. 2024, provide a compelling link between this mechanism and the phenomena of consciousness itself. Researchers tested this hypothesis using neurophysiology recordings in monkeys, for example, and exposed them to varying levels of predictability in tone sequences. By administering the anesthetics to modulate levels of consciousness, they observed a significant change during loss of consciousness. For example, the normal inhibitory control of alpha, beta, and beta waves was disrupted, leading to a disinhibition of gamma oscillatory and spiking activity. This result supports the idea that alpha beta inhibitory control is a key feature in conscious processing. Integrating neural oscillation models into AI systems, these discoveries raise thought-provoking questions for the future of AI development. While AI has traditionally been designed with purely digital architecture, often using high-frequency data and training methods, the brain's reliance on a mix of slower versus faster brainwaves oscillations suggests a more nuanced approach. What if AI could similarly utilize different types of signals, including real-time biological oscillations, to balance the need for predictability and novelty? By integrating analog biosignals such as alpha, beta, and gamma waves into AI systems, we could potentially create models that mirror the brain's unique strategy of processing and responding to information. For instance, AI models built with predictive control layers analogous to alpha and beta rhythms could modulate their internal decision-making processes based on the predictability of the input data. This would enable them to maintain a form of cognitive flexibility, similar to how the brain selectively focuses on unexpected stimuli. At the same time, incorporating gamma-like dynamic could enhance the AI's real-time adaptability and responsiveness, making it better suited for complex and variable environments. Although we are far from fully understanding the intricacies of human consciousness, these early insights suggest a potential roadmap for the future of machine learning and AI. By harnessing real-time neural oscillation data from humans or other living organisms, it may become possible to develop hybrid systems that go beyond traditional digital AI. Such systems could be designed to interact dynamically with their environment, capable of distinguishing between predictable and unpredictable information streams in a way that mirrors the brain's natural behavior. The implications for both scientific research and practical technical applications are immense. This approach could lead to the creation of AI systems that not only assist in real-time decision making, but also contribute to advancing our understanding of human cognition itself. With the ability to process complex biosignals in a biological inspired manner, future AI systems could serve as powerful tools for exploring the nature of consciousness, bridging the gap between digital and biological intelligences, and ultimately contributing to the evolution of new kind of intelligence and intelligent technology. Okay, that's all I had for today. I think next time we can talk about traveling waves. I know that it sounds a bit sci-fi, but it's actually not. I promise you that it is a very scientific terminology used in neuroscience discipline. And there are still brain waves, electrical activities of the brain. However, they are defined a little bit differently in terms of what they do and how they move. So we can talk about that, and of course its potential into a future of AI systems as an integration of biointelligence onto artificial intelligence. And lastly, I wanted to also quickly say that should you read this book and have the patience for it, if you find any typos or anything like that, let me know, because I couldn't afford getting an editor. It would cost me about $1,000, which is a lot. So I relied on myself and also the free version of Grammarly to make sure that there are no typos, but sometimes there are, and if you let me know, I can definitely update the manuscript again. Thanks again for watching, and as always, your feedback is welcome, and feel free to like and follow for this channel to grow. I mean, I'm not really obsessed about that, but I know that some people would benefit from this type of information. Thanks. Take care. Bye.